ROS is essentially a communication system, and there are various packages. And for example, Dr. Nguyen and Dr. Dabney, a mechanical engineer, and I have looked into the control system of Baxter. Now we can modify, it's using a PID control, standard control. It can be modified to use optimal control and other things, okay? And that package can be incorporated into ROS, if that was your question.
Yes.
That's one of the flexibilities of ROS, that I can write my own code to do very specific things if I want to. Or I can just use ROS as it is and its packages for applications. And I'll give you an example here in a moment. So Dr. Nguyen is going to modify actually the control system of Baxter to make it more robust and quicker, more accurate. Okay? And that can be done in ROS. That's one of the advantages. So you don't have to start with building the whole software system. You just add the parts you're interested in, as long as you meet the interface requirements. Okay? Does that make sense? Okay. I'm going to talk a bit, and then I'll invite Carol up to talk about our center. This is kind of the bottom line. What are we all about? For the center, which is just starting today, obviously it was approved some time ago, but we're still working on it. There will be a robotics day here in July. We had one last year. There were a number of participants from Rice, from U of H, and so on. The research in multi-body dynamics continues with Dr. Nguyen and others. There's an oyster sorting application that I want to talk about that combines ROS and other things that I'm interested in. NASA Swarmathon continues. There'll be another contest next April. The difference, I didn't mention before when I talked about the Swarmathon, that last year the rovers just identified tags. This year there was a gripper added, and the video that Kimberly showed reminded me of the robonaut picking up the rock. Well, in this year's contest, the rovers actually had to pick up a cube and bring it back to the center. So there was a manipulator arm. And then we're looking into ROS Industrial. ROS Industrial is popular. Southwest Research Institute is sort of the focus of that in the U.S. They're European groups. And then ROS Military is a fairly new concept. All right, so here's some of the courses that we're developing or have developed at U of H. Clear Lake, we introduced an undergraduate course, Introduction to Robotics. The students the undergraduate students have a senior project requirement. And of course, some of us, when we're involved in that, encourage robotic projects. And these students can participate in various competitions. The NASA Swarmathon, of course, that I've talked about. The Institute of Electrical and Electronics Engineers, they have a contest, a robotics contest every year. The graduate courses there's a basic, what I call standard robotics. This is kinematics, dynamics, the rest of that, for the engineering of robots, if you will. There's a robot application and software. That's basically a ROS course. I just introduced a course in mobile robots using ROS. There's a course in open computer vision, that robotic vision. Dr. Nguyen taught that. We have capstones and master's thesis of various robotics processes. And for more details, we have a digital control system, digital signal processing course. I think you all understand that under the hood, so to speak, behind the curtain is a tremendous amount of mathematics, mechanical engineering, electrical engineering. And of course, that's the exciting thing about robotics for a lot of us. And some of you know, if you know Isaac Asimov's Foundation series. We're going to have robotic psychologists one of these days when they get consciousness. So lots of things are coming, aren't they? So anyway, we're not working on that yet. All right. So here is Baxter, and those of you that come over, I'll take a little survey later to see who's coming to the meeting. Baxter is a special design. The company Rethink Robotics was started by Rodney Brooks. He brought you the company iRobot and the Roomba carpet cleaner. He's kind of a robotics prodigy. And the idea of Baxter was it could work alongside of people. Most robot arms are either position control, they move somewhere, or they're velocity control, they move with a certain speed. Baxter can be force and torque control, so if his arm comes to you, you can push it away, all right? All right, so Baxter has cameras, he has a depth sensor, so on, and those of you that come on the tour, you will see him playing golf and doing other things. Okay, we have a number of other people who are interested in robotics. Dr. Dabney is the head of the system engineering group. He was my student, actually, got his PhD in mechanical engineering at Rice. He heads that. Dr. Findler is here in software engineering. He's interested in virtual reality and other things. Dr. Nguyen, you've already met. Dr. Liu is interested in sensors, particularly wearable sensors. One of the things that has advanced robotics as much as computational power is improvements in sensors. For example, we have a new TurtleBot called a TurtleBot 3. It has a LiDAR, a laser sensor on it, and the whole system is only about $500. And that would have been many thousands of dollars a few years ago. Dr. Unwala is here, and he's particularly interested in reliability studies. One of the things about the robots today, as the videos showed, the robustness and the reliability is not what we'd really want for many real applications. And of course, it involves computers, and that means crashes and all the rest of it. That is, computer crashes, not just robot crashes. Dr. Wu works in software engineering, in gaming. Dr. Sakalu has done a lot of work in image processing and medical applications. We have others that are interested. So we've had lots of STEM youngsters come through. Everybody loves Baxter. So if you mention robots today, I guess it gets people's attention, doesn't it? All right. The inputs and outputs of the center, the bottom line, so to speak, is we will look for grants from the state, from federal agencies, other DARPA, et cetera, and investments from industry, whether it's industry, and we think of local industry in Houston. We want to attract students, visiting professors, specialists to come. We're thinking of a seminar series, and the output would be from the academic side, publications, conferences, graduates who are good in robotics, and then research and solutions of technological properties, whether you're interested in patents, intellectual property, and products. The university is not going to be a manufacturing group, but we have many manufacturing groups in Houston, as has been pointed out. And then our students get jobs, we hope. Okay. Here's an example, a very good example of a collaboration between local companies and the university. This was a grant that was going to go into the Department of Agriculture. We didn't have time to finish it to meet their requirements this year, but a local company, it's called Prestige Oysters, they deliver oysters to restaurants all over the area. So the idea here is that before we get to this conveyor belt, the oysters are shut. They're on the half shell. They run through a big refrigeration unit that uses ultra-cold nitrogen gas, so they're frozen. So the half-shell oysters come speeding down here in a frozen state. Well, some of the oysters are not acceptable. The meat may be missing, the shell is cracked. You wouldn't present them at a restaurant. So we have a first camera and a robot arm that the camera would recognize oysters that are not acceptable. The arm would pick it up and move them off in another direction. The rest of the oysters, and these are moving pretty fast, would run down the conveyor belt. There's a second camera, and that camera would locate the oysters, and these two robotic arms would pick the oysters up and put them in these cartons. And they're put 12 in a row, 12 in a layer, 12 layers in a carton, and then they're shipped in that state. So the idea of this is a lot of good engineering and manufacturing, because this would have to be built. There is, again, a good engineering, system engineering. All of this has to be coordinated, which is a big part, the requirements and so on, and that's what we worked on. And then there's research, exactly. These are fast-moving creatures, critters, whatever, and we'd have to figure out, we have computer vision algorithms, but they'd have to be tailored for this particular application, since it's a unique, fairly unique application. So those are the kind of things that make excellent grants if we want collaboration with other companies, other industries, and academic work. Okay, we have a current plan, and I'm going to let Carol Fairchild explain our current work and our future.
All right, so my assignment is to tell you guys about the plan for the center. We are interested in providing teaching, research, and service to JSC and to local industry. Our work in Ross, by offering the book, by the classes that we have that center around Ross, and the collaboration that we've kind of started building up with colleagues in the area are important ingredients that we can offer to the robotics community of Houston. For the next 6 months, these are our objectives. The first one, to offer a graduate level robotics specialty in computer engineering. That step is complete. You can achieve a master's in computer engineering with a robotics specialty now from the University of Houston Clear Lake. The next is to work on a website for the center. That is in the process. We are going to be using the website to promote Houston, what we offer to the Houston robotics community. We plan to offer NASA JSC any ROS support that they need. And we are planning to do ROS workshops and seminars in our UHCL Center for Robotic Software lab. You'll have an opportunity to see our brand new lab on the tour this afternoon. We have upgraded the computers in the lab because ROS and Gazebo require such high-level graphics processing capabilities that we needed to revamp that lab. So that is up and running. Or we can provide that training at other facilities, like if your company has a facility for that. Phase 2, beyond 6 months, we want to continue to develop relationships and collaborations with academia, NASA, industry, federal agencies, and other local businesses. We are having, like was told before, we are having our Robotics Day on July 21st. And we welcome you to come and hear these robotics students. It's going to be both graduate level and undergraduate level. They are going to be from universities across Houston, and they're going to present their current robotics projects. This has been, since this is the second year, this has been a great collaboration in building the relationships between the universities, and it gets us knowledgeable on what other universities are teaching and what research is being done there. The participants are University of Houston main campus, San Jacinto College, U of H Central, and Rice. So just a reminder to those of you in industry, these presenters could be potential employees, interns, or full-time employees. The other thing that we do is we host lab tours for people that are interested, and that builds discussions on what we're doing currently and what we find, what robotics we find out in industry and other organizations. We also plan to host an interchange, a monthly interchange of robotics presentations from local professionals to promote the interchange of current technology and encourage connections within the robotics field. We have had professors from U of H and from Rice come and give presentations on their robotics projects, but we'd like to invite industrial experts to come and also present their projects, so we have an interchange of information and we know who's working on what problems. We also plan to develop workshops and seminars specifically needed to fill targeted ROS training in a particular area that a company or NASA might need to strengthen in a particular, for a particular project that they're working on. The bottom line is we are interested and capable of accelerating your ROS learning curve. And from people that have done that, and I think Dr. Harman has shown the breadth of ROS, it's a pretty steep learning curve. We also want to work with our collaborative partners to identify and solve challenging ROS automation and robotics problems. Across Houston, there are many people in industry that are working on different aspects of robotic problems, and others that have knowledge, like NASA JSC, that have knowledge on how to solve some of these problems. And we want to build a network of robotics expertise so that we can shorten the time frames of these projects. This is pretty much based on the open source nature of ROS, which has kind of laid a foundation for organizations to collaborate to advance the whole realm of the robotics field. Next, we want to form and lead proposal teams with our collaborative partners to target research opportunities like Dr. Harman went over. In the areas of government agencies, specifically these federal agencies, and also within our Houston flagship industries, oil and gas, healthcare, biomedical research, a lot of what Dr. Ambrose went over today, manufacturing, that's huge in Houston. Each of these industries are developing robotic solutions to meet their particular needs. But we feel that these industries can benefit from this collaboration that we're kicking off here today. So for our next steps, we are kind of accomplishing that here today. We want to meet with and collaborate with local industry management to identify investment and grant opportunities, and also meet with our academic colleagues and other partners to discuss participation in the center. So our goal is to establish this collaboration across Houston to link organizations that can benefit from the other's knowledge and research in the robotics field. And I'm handing it back to Dr. Harman for probably the most slide of the day.
The next slide will be of interest, but we'll get to that in a moment. Tell you a story that happened in Florida at the Swarmathon. Someone was talking about Curiosity rover. You all know Curiosity's running around on Mars. And somebody pointed out that Curiosity killed the cat. So obviously the nerds said, how did that cat get on Mars? Well, whatever. Okay. Bad joke. Now, you know, okay. And there was another, let's see, there was another one. What do you call a robot that loses its way navigating? R2 detour. All right, enough already. Okay. Now, one of the things I'd like to do is invite the audience, and I think the timing is working perfectly, invite the audience for a few minutes, maybe to ask some questions for our NASA presenters, because they didn't have really question time. Does anyone have questions for them or for Court?
Norm Chaffee.
Norm Chaffee, yes.
Tom, after many years at NASA and then outside of NASA, I've got a great passion for education outreach to the middle school and high school level, and just following up on your next steps here. I'd be interested to know if you and maybe Dr. Ambrose and that kind of stuff would be interested sometime in the next school year to put together a little, 9 a.m. to 2:30 p.m. thing hosted at NASA or here for selected high school groups. Do that at least once, where your students and faculty could come and talk about some of these things and excite these kids from the Houston area and, maybe as far as Beaumont or, wherever, just a day of really opening up this field to them, showing them what's available and where they can come to learn more. I love doing things like that. I'd love to work with you. I'm on the KIP Private School STEM Advisory Board. They would love to probably come and bring some kids. So just want to plant a seed. All right. That might be something that we could jointly do together.
I think that's excellent. We do quite a bit of that for STEM. In fact, we've had visitors from, what is it, Carol, 3rd grade to whatever, and lots of things. We've all been involved in FIRST. In fact, Dr. Shee there I see is wearing the Robonaut shirt. I've been a judge and a safety officer. Carol has been involved in lots of the robotics contests for high school groups and even younger groups. So yes, the summer camps, for example, the Cybersecurity Institute, as we speak, is having, I believe, a summer camp for young students. So NASA obviously has an outreach to this. Did you want to say anything about that, or is that?
So a question back to you. You're thinking focus course on software development?
Well, not necessarily, but just the robotics, automation and robotics field, bring kids. I don't want to get too specific yet because they would get that. But, you bring some of these kids in from KIP or other schools, and they just have very infantile understanding of these fields. I think if you could just show them the prospects and how much fun and interesting it is, you generate a pipeline full of kids like you're talking about doing here.
I couldn't agree more. I know that I'm in Houston because of NASA, because going to the moon, and we've really got a great attractor here, and to get the kids interested in the STEM fields. I think that's coming along. There are a lot of people working on that here at the U of H in their admissions. I'm sure at NASA you have outreach. I know they have outreaches and so forth. So that's an excellent idea, and we want to carry that forward. Maybe summer camps and
well, even during school, they just.
Well, yes,
sure, but we can talk about it if you're interested.
I am.
Maybe I could get together with you and Rob and
Yeah.
some other folks and talk about doing something like that. So.
As you wish. Okay, great. Any other questions? Yes, ma'am.
Actually, to lead off on what he just said, there is interest in what he's saying. I brought my kids today, as a matter of fact. I'm with Allen Community College in Castle Bud. We have been to the STEM competition that you're referring to, but they do not go into robotics. So the robotics aspect, you could do something that leads off of that. And I know that there's an interest because the schools, like you said, do have robotics competition, but there's not a lot of them in this area. It's growing, but it's not quite established right now. They do get partnerships with, usually with somebody with like Dow or NASA. And so I know they just introduced it in the elementary and high school level at their school, but they also have it at the 4-H level. And so it is a growing field, and their kids are interested in it. So not only would I would think maybe even thinking about maybe having a day, because I think my kids would love to go to NASA and check all the actual robotics in action. That would be awesome. But maybe even think about maybe having a mini competition because they don't have a lot of places to go. They have a lot of places at the end of the year, but they don't have any, like maybe say like in the January or the end of the year, like in December time. And it helps them get prepared for instance, in Houston, they competed at the Houston Outside Show. They actually had a competition as well.
Yeah, come and talk to me about that, because
Good.
we've got some of that going on.
Yeah, okay.
Excellent ideas, yes. Okay, other questions? All right. Oh, sorry. Charles, Dr. McKay. Yes.
Tom, I think it would be a really good service if presentation slides that we used today could be made available on a website that would be SCE-related website. There are a lot of us, I'm sure, that would be very quick to download those.
Well, with permission of the presenters, you can have mine for free. It's not a problem. But with the presenters, we'd have to get their permission. But where's Jim? Jim Townsend. He takes pictures. Do you need, or you need their permission, obviously. Do we need something more formal? I mean, I'm thinking of putting them on our website when we get our website built.
If they have already signed permission for us to take their pictures and interview them, then that would blanketly cover any of their presentation materials. But if they don't know that. If they don't know that, then we have to.
We work for the U.S. taxpayer, so
Yes, they're our employees. We pay. Well, no, but so are we here at the university. It's the state, but the same thing. Yes, it is. You have a question? No? You're okay. All right. So now we move on to other things, and we're going to have a lunch here. And this is really good timing. It's 11:53. And I want to ask about the tour, and I'll give you some directions in a moment. How many people are going to come over to the Delta building to do a tour? All right, that's a good turnout. And to tell you about that, we are, let's see if I can stay by the microphone. This is the bio building. And here is, if you parked in the front, this is the parking lot. If you go out here and turn right, here's a parking lot. If you drive this way and make a sharp left before you leave campus, that's lot G. And I think you can, I know you can park there. And this is the Delta building. This is the University Forest Apartments. Don't go in there. Here's the Delta building, all right? And in the Delta building, you're parked out here in lot G. You'll walk through this door. There'll be some signs there. And Baxter, you would walk in and turn right. This is Baxter's lab. This is the simulation lab. This is actually the computer security lab, the CSI group has that. That's basically just looking at computers. There's not much going on. Baxter, we're going to give some demonstrations. And then on the second floor is a laboratory for the rovers that we developed the software for to compete. The way the Swarmathon works, I guess now that I mentioned it, is we don't send our physical rovers to Florida. We send the software and they load it on their own rovers, and that's controlled by the judges there. Once it's shipped, we have no control over it. There's nothing can be changed and so forth. So again, if you're driving, just come on Just go out of that lot, make a right, go over the bridge, make a sharp left, make another sharp left, and park in Lot G. And then I'll meet you over there. So, anything else? Are we ready to eat? It's 11:55. I think we did. Dean, would you like to close it out? Come and...
Thank you, Tom. All I want to say is that it was a great event. And it was great because of your participation. So I'd like to thank the presenters especially. It was great to see what's going on. And thank you again for coming. I hope you enjoyed this morning, and I hope the collaboration will get started right now.